Hey guys, Mr. Milton here. Today we're going to talk about graphing quadratics, kind of finishing that up. At the end of this video, you should be able to find the axis of symmetry and the vertex from a quadratic function, and you should be able to graph the quadratic function. So let's review what we learned in the last notes about finding the axis of symmetry and the vertex. Remember, we can find the axis of symmetry, that's the line that cuts our parabola in half, by using opposite b over 2a. And so in this equation, we might still be wanting to identify a, b, and c for ourselves so that we are organized. So we have x equals opposite b, so negative 6 over 2a, and a is 1, so negative 6 divided by 2, which is negative 3. So our axis of symmetry is x equals negative 3. Remember, x equals because it is a vertical line. We can find our vertex by just plugging negative 3 into the function that we're working with. So y equals negative 3 instead of x plus 6 times negative 3 instead of x plus 11. So that's 9 minus 18 plus 11. And so 9 minus 18 is negative 9 plus 11 is positive 2. I already know that my x value is negative 3. That's why I plugged negative 3 in for my x's. And then I solved this out and got positive 2. Right? So there's my vertex at negative 3, 2. Okay, so that's what we did yesterday. Now we're going to take that to the next step and actually finish the graph. So we're going to graph this function, x squared plus 6x plus 11. Okay, first we're going to put our axis of symmetry and our vertex on the graph. Our axis of symmetry, x equals negative 3, 1, 2, 3, negative 3. Remember, that's a vertical line. I'm going to draw a dotted vertical line here. This is not really a part of our graph. It is the line that cuts it in half, but it's not really a part of our graph. But we'll use this as a tool to make our graphing a little bit easier. Okay, then we have the vertex negative 3, 2, negative 3, 1, 2. That's our vertex. Okay, checking a couple things with ourselves, we should see that a is going to open up because a is positive. Okay, makes sense for us right now. If we had a dot at the top and we thought it should open up, then we might need to evaluate what we were doing. Okay, so now we're going to create a table of values with the vertex in the middle of the table. Remember, we find the vertex really before we make our table. Our vertex, x is negative 3, y is 2. Okay. So what we're going to do is we're going to plug in some values around the x and around the x. Okay, I'll pick some numbers that are lower than it, some numbers that are, oops, I messed up. Okay, some lowers that are lower than it, negative 4, negative 5, there we go. And then negative 2 and negative 1. Some numbers that are higher than it. Alright. So what we're going to do now is we're going to plug those values in and see what they come out to be. And so when we plug those values in, we get, let's say negative 5 squared plus 6 times negative 5 plus 11. Okay, and remember that's all coming from up here. All right, and so that gives us 25 minus 30 plus 11. And so that will give us positive 6. So when x is negative 5, y is positive 6. We can do the same thing with negative 4. Squared, 6 times negative 4 plus 11. So that's 16 minus 24 plus 11. 16 minus 24 is 8, or negative 8 plus 11 is 3. So our value here is 3. Okay, we can do the same thing with these other values. Negative 2 squared is 4. 4 minus 12 is negative 8. Negative 8 plus 11 is 3. Negative 1 squared is 1. 1 minus 6 is negative 5. Plus 11 is positive 6. Okay, so filling out that table. And now we just plug in our values. Negative 2, 1, 2, 3. Negative 1, 3, 4, 5, 6. Negative 4, negative 5, 6. Okay, and so we have that U-shaped curve we can feel really nice about because we know the parabola, that quadratic should come out to be a parabola. Okay, and so what do you see about the y values? The y value, one step above the vertex, is the same as the y value one step below. And by that I mean when we're negative 4, which is one less than negative 3, and negative 2, which is one more than negative 3, they're the same value. Okay? And this is because of the symmetry of a parabola. That's kind of where our axis of symmetry can make our problem a little bit easier. Okay, you kind of see, well, I kind of showed that here by only showing half the steps. We'll look at it a little bit further on the next page. Okay, let's look at a couple more examples of this, because once we have the vertex and the axis of symmetry down, we kind of have the graphing down. So again, we're going to A, B, C, identify A, B, and C. A is negative 1, B is 8, C is negative 9. First step first, I'm going to find the axis of symmetry. So axis of symmetry, x equals opposite b over 2a. So x equals negative 8 over 2 times negative 1. And so that's negative 8 over negative 2, which is 4. So x equals 4. Okay, and then I want to find my vertex. Remember, I find my vertex by plugging 4 into the equation for x. Negative 4 squared plus 8 times 4 minus 9. So 4 squared is 16, negative that is negative 16, plus 32 minus 9. Add all these together, you get 7. So the vertex then has our x value at 4 and our y coordinate at 7. And then after that we want to make a table. Okay, our table doesn't have to be fancy, but we know that in the middle of our table we'll have 4, 7, have some numbers lower than 4, numbers higher than 4, okay? And when you do this, you want to make sure that you go up and down the same values, okay? So, then we plug in our values, we see what comes out when we get them. So I'm plugging 5 in here, and that'll be negative 25 plus 40, which would be 15, minus 9, which would give us 6. I'll plug in 6 here, so that's negative 36 plus 48, which gives us positive 12, minus 9 will be 3. Okay, now I'll go through and show you the shortcut here. And the shortcut isn't a whole lot of short, but 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, but it's enough to appreciate having to do a little bit less work. Okay, so here's our vertex. We already found our axis of symmetry to be x equals 4. I'm going to draw my axis of symmetry because that helps me out a little bit. Okay, now here's where our shortcut gets nice. We have 5, 6. We have 6, 3, 1, 2, 3. Our axis of symmetry, remember we said, is a place that our cuts our parabola in half. And so what we can do is, instead of having to plug these values into the equation and see what they come out to be, we know that if we have a point to the right of the line at some place, we will have that same point the same distance away on the left side of the line. So this is 1 to the right here. This will be 1 to the left. This is 2 to the right here. This will be 2 to the left. And then from there, these 2 points that we found, without having to plug them into an equation, we can put their coordinates in our table later. So we got 2, 3, and we've got 3, 6. And there's our table. And we should see that, hey, these have the same values, these have the same values, as long as we evenly went through the same distance from the vertex, right? This is 1 away from the vertex, 1 away. This is 2 away, this is 2 away. And so we have our parabola. Kind of got to cut our work down just a little bit, okay, instead of having to plug all those values in. Okay, that's where axis of symmetry comes in and is helpful. All right, let's go through this next one as well. Again, identifying A, B, C, finding the axis of symmetry, which is going to be opposite B over 2A. So 2 times 1/2, which would be 1. And so our axis of symmetry is at x equals -4. Okay, we can find our vertex by plugging that -4 in. So 1/2 -4 squared plus 4 times -4 plus 3. So that's 16. 1/2 of 16 is 8. Minus 4 times 4, which is 16, plus 3. So 8 minus 16 is -8. -8 plus 3 is -5. So our y value is our y coordinate is -5. Our x coordinate is -4. -4, -5 is our vertex. Okay, and then from there I'm going to make my table. And remember, in my table I want -4, -5 in the middle, -3, -2 here, -5, -6 here. I will 1, 2, 3, 4, 1, 2, 3, 4, 5. I will plot my vertex. I will draw my axis of symmetry in here so I can use it to shorten my work later. Okay, and now I'm going to plug in these values into my function to see what I get. Okay, so I'm going to plug in -3 and -2. I'm going to stay on one side. I'm either going to do the bottom or the top. If I do these two, then I don't know how far away -6, -2 are going to be. So I'm going to plug those in. 1/2 3 squared. I should have thought about that. Alright guys, I'm glad I haven't done this too much yet. So here we go. I noticed that this value in front of a is 1/2. If I do this 3, I'm going to get decimals, and I won't be able to graph decimals very easily. So my mistake, your opportunity to learn here. Instead of going 1 away, I'm going to go 2 away. So on the bottom, I'm going to go to -2 and 0. Okay, so going by 2. And on the top, I'm going to go to -6 and -8. Okay, again, I'm doing that because I have 1/2 in my function, and that's going to make all the numbers that are odd come out to be decimals, which won't be nice for me. So, changing that to -2. So, -2 squared is 4, half of 4 is 2. See, much nicer. 4 times -2 plus 3. So, 4 times -2 is -8 plus 3. So, I have -6 plus 3, which is -3. I can do the same thing with 0 squared. 4 times 0 plus 3. That's 0. 0, 3. All right. All right, now, I did that half, the bottom half, and so I don't have to do the top half. I know that the top half is going to be the same. So I have -2, -1, -2, -3, 1, 2, 3. I have 0, 3, 0, 1, 2, 3. I have, now can just count over. Since it's 2 away on that side to the right, I know that I'm going to have 2 on the left. 1, 2, 3, 4 to the right. 1, 2, 3, 4, back graph. On the right, or on the left side. Okay? And so here's my parabola. So just a little bit adding on to finding the vertex and the axis of symmetry here. Once we found that, we were able to find the rest of it by plugging our values into the function, making sure that we evenly distribute. Okay, so you see here I'm 1 away, -1, -1, +1, +1. See, I'm 1 away from the value here. I'm doing the same thing here. I'm going 2 away, 2 away, +2, +2. Okay, so making sure that I keep that same distance so that I can keep the symmetry and shorten my work up a little bit. Okay, if you can do this, this will help solving quadratics by graphing become even that much easier. All right, see ya.